Welcome everybody to today's webinar. My name is Jill Browning and I will be the moderator for today's webinar, Protecting Your Reverse Osmosis Plants with Ultrafiltration Technology. First of all, hopefully you should be able to hear me speak at the moment, but I do want to mention mention that should you have any difficulties throughout the presentation today, that there are two different ways to connect to the audio. You can use either your computer or call in through a phone line. So should you have any difficulties, please feel free to switch back and forth between those two options. And also, due to the large number of attendees that we have on the presentation today, we have gone ahead and muted everybody's phone lines. But no worries, you can still interact with our speakers. And in terms of doing so, you can ask your questions through the questions panel anytime throughout the webinar today. And then at the end of the presentation, we do have some time set aside to go over a Q&A session. So please feel free to ask any questions that come to mind, and we will try to get through as many of those questions at the end as time allows. Additionally, we have made available our collection of on-demand webinars that we've conducted over the last few years. You can access more than 40 on-demand webinars over at www.veoliawatertech.com. So feel free to go over to the website and check out through those various topics to see if any of those may be of interest to you. One other housekeeping note that we have is a PDF participation certificate will be made available to you at the conclusion of the webinar. You should receive that within about 24 hours or so. So be on the lookout for that if that's something of interest to you. Also, at the end of the presentation today, you will receive a quick survey requesting feedback. Shouldn't take more than about a minute or so of your time. And for those of you who do complete that survey, you'll be entered into a drawing for a chance to win a $25 Amazon gift card. So if you would be so kind as to fill that out for us, we do greatly value your feedback. And with that. Now, before we hop into the main part of our presentation today, if you're not familiar with Veolia Water Technologies, we are a leading water and wastewater technology provider, and we offer our clients a variety of technologies, services, and project solutions. And we support our clients through a variety of different markets, whether it be industrial, as you see on the screen here, as well as the municipal market as well, to help support their water and wastewater needs. So with that, now I'd like to introduce our three speakers for today. Tim Clark is Vice President of Technical and Execution for Veolia Water Technologies North America. Tim is a chemical engineer with over 30 years of water treatment experience in chemical treatment, process automation, membrane technologies, and implementation of operational improvements. He's been with Veolia for over 15 years and has a BS in chemical engineering from the University of Tennessee. Our second speaker today will be Mohammed Awad. He is a senior process engineer at Veolia Water Technologies with 24 years of industry experience. His role as a specialist in Veolia involves defining complex treatment chains for a variety of applications, including industrial, mining, ultra-pure water, desalination, water injection, and many others. And finally, our third speaker to round out the presentation today is Jamie Hawes. Jamie is the sales manager for Veolia Water Technologies' mobile water services offering within North America. He has more than 30 years of water treatment experience and extensive knowledge of both process water and wastewater applications. And with that, I would like to now turn it over to Tim to talk with us a little bit more about ultrafiltration.
Thank you, Jill. So I guess as we started, the most important place to start would be just to kind of say, what is ultrafiltration, or UF technology, as we like to refer to it. Ultrafiltration really involves a pressure-driven separation of materials from a feed solution. The technology as we use it achieves separation through sieving and is used to remove particulate and microbial contaminants, but it does not remove ions or molecules of low molecular weight. That is one of the distinctions we do draw. The process typically operates with a feed pressure of anywhere from 4 to 100 psig. And what it really means for those of you who want to work with or around them, that the UF plants can be very well automated. They have low operational labor requirements to do what they do. And depending on feed water quality, these systems do require periodic cleaning or backwashes, but they can go very long intervals. So because of the absolute nature of this filtration and the small pore size, it is becoming a very highly utilized technology across industries. What you will see here is a little bit that kind of breaks down the main membrane separation technologies that we see out there. UF does reject solutes ranging from a size of 0.005 microns and larger. And as you can see in the figure, it kind of compares that to the other processes you may be familiar with. One of the most important things to remember is that the pore size distribution and the uniformity rather than the chemical nature of a solution is what determines how well UF separates. As I did say, the UF does remove down to 0.005 microns in larger particles, and it also achieves a 4-log reduction of viruses and removes almost all microbiological organisms, which makes it a really good fit for downstream processes that may be either intolerant or in need of removal of bacteria. Again, you can see kind of how the different filtration processes align and what they remove. Maybe a little better than the previous slide, but this is a chart that we're all fairly familiar with. As I did highlight, UF is really good at removing things from surface water like suspended solids, algae, and bacteria. It removes viruses as well. For those of you who are familiar with processes for downstream membrane technologies, there's a term we refer to called sill density index that relates to the fouling factor of the water. A UF treated water will almost always be at less than 3 SDI, if not significantly better than that. So what it is really good at when we look at running downstream processes or adding this water is we can clean this water and filter it to a level that it can be processed a multitude of ways. It's regularly used in treating of wastewater in the food industry for concentrating proteins or separating oil and water emulsions, even removing pathogens from foodstuffs. But we use it a lot, and one of the things we're here to talk about today is ahead of RO to extend the lifespan and reduce the fouling. As we talk about UF, it is a technology that there are a multitude of membranes that are out there on for use. And one of the things we do when we look at any project is try to select the right membrane process for the right applications. And they're everything from the hollow fiber membranes that are in a pressure vessel that you see in your upper left to what the hollow fiber submerged vessels that you see just below it, where the hollow fibers are arranged in almost a sheet-like pattern and submerged into the liquid to be filtered. There are also tubular, spiral-round, flat sheet, and ceramic membranes. And when we look at these different types, there's really two main breakpoints. One is an immersed configuration UF, where basically it involves a large tank that is open to the atmosphere and a series of membranes are lowered to that tank. And then the other one is a pressure vessel style UF, much like the hollow fiber membranes that you see here are the tubulars, but these membranes are individually housed within cylindrical tubes. And a pressure pump draws water out and through the membrane, and the flow configurations can be operated in a number of ways with these membranes. As we talk about the flow configurations, one of the most important concepts that we look at when we talk about these is fluid dynamics. The fluid dynamics can be explained briefly as how fluids flow through the membrane system. These dynamics have effects on energy use and the rate of buildup of solids and even filtration efficiency. So the selection on the flow type is dependent on the concentration levels and the type of suspended solids that we're going to feed one of these units. We have both inside out or outside in. And we also have dead end or tangential filtration. With dead end flow, the water feeds perpendicular to the membrane surface. Molecules and particles smaller than the effective pore size pass through to the opposite side, while larger matter builds up in a somewhat of a layer on the membrane surface. The pros for this is that it doesn't take a lot of energy to run this type of system. We don't have to recirculate any water, and no excess solids are carried through the system, and all particles will build up on the membrane. It also is a smaller footprint. Some of the drawbacks for this is that it backwashes a bit more frequently. And it also, we also run lower fluxes, or the amount of water that we place across the membrane to get in a certain amount of filtration. When we look at the cross flow designs, it has feed water flow parallel to the surface of the membrane, and while flowing along the length of the membrane, water and small particles pass through the membrane while some solids adhere to the membrane surface. As a result, these solids continue down to the end of the vessel, and shear force is generated by the tangential water flow. It also scours the membrane and helps keeps the surface cleaner, and so it allows these units to take higher levels of solids and even be in higher fouling situations. The good thing about it is the shear forces that we generate do keep the membranes cleaner and do eliminate the number of backwashes needed. There is a higher liquid removal rate because the solids cake layer is kept thin, and the system flux is typically much more consistent throughout the membrane system. It also sometimes has a longer membrane lifespan because we're cleaning it less with either chemically induced methods or with CIPs. The cons are that it needs recirculation because not all the water is drawn through the membrane at any given time. Recirculation is needed to prevent excess water wastage. It also takes a bit higher energy because when you're recirculating water, we have to run pumps, and when we do that, we use a bit more energy. So all of that being said, there are some advantages to UF over all the other types of filtration, whether they be cartridge filtration, whether they be single or multimedia filtration, or even vortex-assisted CMF filtration. There is a high and consistent product quality out of UF. You're pretty much, with a varying water stream, always going to get less than 0.1 NTU. SDI is well below 3. You can have a tolerance to a tremendous amount of feed water qualities. The UF can take a lot of water that a lot of things don't, and you never really notice it from an operational perspective. It has a small footprint and a much less weight than media filtration, and it's much less costly to operate, as you can imagine, than using cartridge filtration. It uses low water. The rejected or wasted water from a UF system is typically greater, 95% or greater than the flow that it takes. The cleaning operations are very easily automated, and it does not take a lot of labor to operate. The other thing is that when you operate one of these, they're very easy to troubleshoot. You can look at the integrity of the membranes and know if you have broken fibers or whatever, and address those very easily on site without having to call in specialty providers or whatever. But the most important thing, and what we're here to talk about today, is they are very good at extending RO operations, lowering cleanings, and extending the lifespan and operational costs around ROs. So leading into that, I will tell you that UF is very good at reducing the fouling of RO membranes and lowering their operational costs. When you're looking at using a UF, we significantly reduce the chemical cleaning, because, as you can imagine, if we can keep all the bacteria and small colloidal particles less than 1 micron that are always leading to fouling of these types of membranes, we reduce the chemical cleaning frequency. So you don't have that need from an operating cost. You also don't have that expense or the concerns of trying to handle that cleaning waste. With removing the bacteria, you remove biofouling from downstream membrane processes, and that is huge because biofouling is probably the least understood and highest fouling source for all ROs. Then the last thing is, when we have UF pretreatment ahead of an RO, it allows us a lot of times to run at much more aggressive flux rates, meaning that we can use fewer membranes to process the same amount of water. And from a practical perspective, that'll lower your capital investment if you're looking at installing an RO system. So it is a very, very good thing to do ahead of RO. It not only is good there are a myriad of uses. As I've mentioned before, it's used a lot in the food industry, from everything from concentrating proteins to clarifying fruit juices. We also use it for pathogen removal in both the food and the pharmaceutical industry and the water streams. It's used in even chemical separation processes as processing ROs. It's good. Certain types of ROs are very good except at separating oil and water emulsions and are used readily in recycling wastewater for reuse in many projects. It can also be used in place of clarification equipment. There are UF configurations that we use where we can do coal lime softening or precipitation processes for metals removal, do them in situ, pass it straight through a UF, and bypass the use of a clarifier, which saves a lot of footprint and the operational demands of a clarifier. And that's what we do when we talk about cooling tower blowdown metals removal and systems like that. And then lastly, as I said, it is a tremendous pre-treatment of RO feed to eliminate the fouling and things that make RO operation much more difficult for operating personnel. And so with that, I would like to turn it over to my colleague, Mohammed. He is a senior process engineer, and he'll give you a lot of great information on how we normally look at these processes.
Thanks, Tim. So I appreciate the opportunity to present to you guys today. So the presentation title that I'm going to give is Mobile Ultrafiltration, a Temporary Treatment Option. So what we're going to be talking about is the UF mobile asset by Veolia, the components of the asset, the features of the asset, the applications, and the support options that Veolia can provide for you as a client. So first, I'm going to talk about the membrane technology employed. So it is a pressurized outside-in membrane configuration that operates in a dead-end mode only. It has 30 nanometers nominal pore size and a large filtration area around 77 square meters. And what this basically means is that it has a wider tolerance for varying feed water qualities. The membrane has what we call a higher long-term permeability. So as you all know, the permeability of the clean membrane is normally starts off being very high. And as the membrane gets clogged during filtration, that permeability starts to deteriorate until it reaches the end point. So the travel between these two membrane states for this membrane technology that we used is kind of slow. So secondly, the membrane technology or the chemistry of the membrane is a PVDF chemistry. So it is highly hydrophilic, and this means that it is less prone to fouling by organics. The membrane is also, the PVDF membrane is known to be high in chlorine resistance and high in, it has a high breakage resistance as well. Then the features of the asset. So the mobile asset, ultrafiltration asset by Veolia, is designed to be compact, standalone, plug and play, high flow mobile solution. It is designed to be as independent as possible with all auxiliary systems already installed within one trailer solution. It has 4 UF trains in parallel, which gives the end user an excellent flexibility in terms of capacity in case one skid goes offline due to any reason, whether that be cleaning or failure or whatsoever. The trailer is complete with the screens, backwash pump, backwash tank, CIP system, neutralization facility, instrument air system, air scour and integrity test facility, chemical system including chemical storage tanks and dosing pumps, control panel, and electrical panels. Next slide. So operational features of the mobile UF. First, it is very simple to operate. So thanks to the fully automated operation during filtration and backwash, all the operator has to do is just to configure the backwash sequence triggers, whether that be on time, filtrate volume, TMP rise, and then the system is going to take care automatically as any other usual UF system. The asset has a high flow capacity, so it is probably one of the highest in the market, up to 1,500 GPMs, which is equivalent to 340 cubic meters an hour. The asset can measure turbidity online, turbidity of the feed, turbidity of the overall filtrate, or individual trains, UF trains. It is programmed with some semi-automated sequences to make the operation easy. So you have a chemical preparation automated, semi-automated sequence, a cleaning sequence, a neutralization sequence, and the operator can even force a hydraulic clean of a specific skid when required. The main facility of the asset is the mini CIP chemical cleaning facility. So it's basically nothing but a shorter CIP. But although it is more frequent than a CIP, it is much less frequent than a CEB, which is the chemical enhanced backwash for those systems. So it basically involves dynamic cleaning of both sides of the fiber in a closed loop mode. Therefore, it has a lower chemical cleaning frequency compared to CEB. It has also a lower chemical consumption due to the optimum use of chemicals when running in a closed loop dynamic cleaning mode, and also due to the less frequency. And it also generates less wastewater compared to conventional CEB-based systems. And overall system availability thus is higher, and the UF recovery is higher as well, which means you have a more efficient system. The facility also has the ability to fill the tank with an external source of water, and this is key in cases where you have a high scale potential, such as with the cases where we find in the mining market. The water is just about to scale once you start changing the chemistry, and you do change the chemistry when you prepare the chemical solutions using filtered water. So you don't want that to happen and start making the membranes dirtier while cleaning. So you can use an external source of water, whether that be an RO permeate or an ion exchange demon water. It is also, we believe that it has a reduced OPEX solution compared to other solutions, thanks to the reason is that the pre-coagulation is not required. And as you know, the coagulant is probably the single major OPEX component in a UF system that is out of your way. Next slide. So yeah, so we follow the standardized approach for the UF. The slide before that, Tim, please. So it is a standard design adopted company-wide, worldwide. So you can imagine what advantages this will bring to the table, from facilitating the asset management, operator training, the spare part management. We also adopted the latest industry safety standards, which means any safety issue or problem that happens anywhere in the world can be beneficial to enhance the operations and design of other assets as well. It has standard connections and connection kits, which cuts down on the installation time. It has a front of trailer electrical cabinet to ease the connections and again reduce the installation time. It has VFDs on pumps. It comes with two models for the electrical panel, 480 and 575 voltages, to suit different electrical grids in different countries. It uses a Siemens HMI, and it has an upgrade smart monitoring facility, and that's a system that Veolia has, by which we can monitor the asset, and operate the asset from a distance in cases where this is required. Next slide. So HMI features. So the main feature is that it's easy to operate, it's visible, it has the ability to display and adjust detailed parameters, display trends of key parameters. The screens basically follow a sequence of the PNIDs for ease of navigation. It has the ability, Opera has the ability to open and close a valve or start stop a pump locally when required to intervene. And also it has the ability to control external filtrate tank levels by changing automatically the UF filtrate flow in cases where variable demand is required from the downstream client existing system. Next slide. Yeah. Applications. So there's many applications for this solution. So it could be the simple physical filtration applications that Tim had just mentioned, turbidity and removal and improving SDI prior to an RO. It can also be the more complex ones where you need a chemistry aided removal, such as organic matter removal, heavy metals removal when combined with the proper chemistry, such as oxidation, coagulation, softening, and the likes of that. It is also a cost-effective choice in cases where you have a high filtered water flow applications. It can also be used in environmental discharge of industrial wastewater. Typically, this is the case what we see in the mining wastewaters. It can be used also in reuse of municipal effluents. It can be used as part of a long chain in an ultra pure water production system, upstream of an RO, ion exchange, EDI. It can also be used to produce utility water, such as cooling water makeup, boiler feed water pretreatment, general utilities. It can also be used as an emergency backup or in cases where the pretreatment, the existing old pretreatment system that the client has is likely to fail anytime. It will give the client basically a peace of mind to have this trailer available and readily to intervene when required in case of those events. And it can also be used as a temporary solution in cases where the client wants to build a brand new permanent solution. As you know, there's a long lead time associated with such projects from design and build perspectives. And having sometimes those can basically drive the schedule, and it will basically force people to make compromises when it comes to quality of those permanent systems, just because they want the water now. And having this solution readily available can give you the ability to produce water now during the course of building the permanent plant. Furthermore, you can basically learn from the findings that you have of this temporary system and incorporate those findings in the design and erection of the final permanent system. Last slide. So Veolia can support you in various ways, not only renting those mobile solutions. It can provide you with support towards your application development, defining the proper chemistry needed for the application. We can also support you in giving you a value-added engineering assistance, including integration, process and hydraulic calculations, drawings. We can also either operate the assets for you or give you an operation support in cases where you want to operate the assets yourself, satisfying a wide variety of project needs. We can support you to prove concepts towards a performance warranty by installing a pre-commercial full-scale production system as opposed to using a smaller scale pilot system. And last but not least, we can help you in troubleshooting of complex operational problems thanks to Veolia's wide network of experts locally and worldwide. So what we want to say is that Veolia will not only provide you with a rental solution, but would also support you in various ways to satisfy your needs and to make it a success. because we believe that your success is our success. That's my time.
Thank you, Mo, and thank you everybody for participating today. I'm happy to be here. I'd like to share with you some application examples. Veolia basically applies 3 different categories to our mobile service offerings. One is an emergency application, a planned application, or a multi-year circumstance. This particular example was a refinery that initially required a system for a planned outage to substitute for their existing clarifier. But as chance would have it, the existing clarifier went out of service unexpectedly, and we had to mobilize ultrafiltration assets to provide pre-treatment in replacement for their clarifier until it was repaired. This particular system consisted of 2 UF trailers with consecutive or respective storage tanks and repressurizing pumps, which produced very high quality pre-treatment to support their existing demineralizer trains and subsequently kept their high pressure boilers from fouling. Next slide. This example is an industrial client that, as one of the examples Mo mentioned, this client was installing a permanent plant and needed something to sustain their operation until the permanent system was designed, fabricated, and started up. And the application consisted of a single UF trailer with corresponding storage tank and pumps for suspended solids, iron, and organics removal. Once again, feeding a demineralizer system and preventing downstream boiler fouling. Next slide. And this is a good example of a multi-year application. Now, other than the other 2, this is a wastewater situation where a mine needs to reduce their pond levels and subsequently discharge the treated water to the local environment. So this technology needed to remove both the combination of suspended particles and ionic substances. So the ultrafiltration technology is used as pre-treatment to a mobile reverse osmosis system. Next slide. So in summary, why consider a mobile ultrafiltration rental? Well, for starters, it's going to produce a very superior quality of water for any downstream treatment methods that you may have. As Tim had mentioned earlier, the high quality pre-treatment allows for higher recovery of downstream treatment processes, which reduces the size of that particular equipment, subsequently reducing the capital cost and space requirements. Downstream equipment maintenance is dramatically reduced. Next slide. This technology adapts to varying levels of inlet water chemistry and potential spikes in feed water contaminants. Our particular ultrafiltration trailer offers the highest capacity single unit on the market, up to 1,500 gallons a minute per trailer, which again reduces the footprint requirements for these temporary applications. And this technology is ideal for pilot situations to prove a principle, or as Mo mentioned, experiment with the technology to fine tune what the permanent situation or permanent system would need to consist of. Other applications might include a variance or an unexpected change in the customer's feed water chemistry. Perhaps an existing system isn't operating successfully or reliably, or in fact, production may have increased in the plant, demanding an increase in water treatment. Next slide.
Great. Thank you, all three of you, for taking your time and presenting that very informative presentation to us. I do want to kick off our Q&A session now. We've had quite a few questions that have come in through the presentation today, so we will try to get through as many of these as possible. And I apologize if we do not get to your question. Somebody will follow up directly with you as well at the end of the presentation today. Also, just wanted to mention before we kick off the Q&A, there was a question on receiving a copy of the presentation today. I forgot to mention that at the beginning of the presentation, but it is being recorded and you will receive a copy of the recording probably tomorrow, I would say. You should receive those. So with that, I will kick off this Q&A. Mo, I think this one's probably best suited for you. Is it possible to use this ultrafiltration technology for drinking water applications?
Okay, so the short answer is no. The reason being that the asset, when it was initially developed, was designed to serve industrial applications. But generally speaking, yes, with some modifications, but that's not the case right now. Probably something to think about in the future in case the market exists.
Great, thanks. Another question here, maybe this one could be for Tim, looking at it. Talking about the maximum limit of feed water turbidity of TSS that the UF can handle within short periods of time.
Well, that is somewhat dependent on the type of membrane that you utilize combined with the relative size of particulates being used. With a hollow fiber designed membrane like our mobile units, TSS tolerance usually is in the range of 20 to 100 milligrams per liter of particulates that are 300 microns or less in size. We certainly are able to handle more, and we have done it for periods of time or in situations, but we recommend piloting to verify that performance and what the backwash frequencies need to be, or if the special CEBs need to be utilized in those applications.
Great, thanks. Looking through the questions here as well. Tim, I think this could possibly be yours as well. Does chlorine need to be removed prior to UF membranes, or can they tolerate oxidants? And if so, how many or how much?
Yes, well, generally speaking, UF membranes are fairly tolerant to chlorine, and also we sometimes feed chlorine as a way to oxidize organics for removal in the UF. There's a lot of divergent recommendations out there from various membrane manufacturers, but it's been our experience that typically we can feed levels from 0 to 1.0 milligrams per liter of free chlorine to these UF membranes without any significant degradation or issues. And we usually desire to keep that in the 0.2 to 0.5 range, but we can certainly tolerate those levels.
Let's see. Mo, let's go this one here. Talking about the typical ROIs or payback periods that you've seen in improvement projects where you've added a UF bank upstream of an existing RO installation.
Yeah, so basically it depends on what you're comparing it against. So is your existing pretreatment immediate filtration? If so, then what we've seen is that you will be able to operate the system with much higher fluxes, means you can produce more using the same membrane system that you have, RO membrane system, and provided that the system is capable of handling that extra flow that the pretreatment can provide. So what we've seen typically is 20 to 25% increase in the water that can be produced from the existing system compared to media filtration.
Okay, I think we can probably combine these two questions here as well. Talking about what is the typical destination for the rejects on site, and then also talking a little bit about temperature limits. I don't know, Mo, if you want to take that one where.
Yeah, sure. So, so the destination of the reject, I mean, it basically depends on what water you're treating. So in cases where you're treating regular cases, when you're treating like river water or the likes of that, the backwash reject normally can be sent through the sewer system, existing sewer systems, provided that it just meets the bylaw limits of that area or that city. In cases where you're basically in industrial wastewater cases like mining wastewaters, we normally collect those reject streams in a tank and then send them back to the tailing storage facility. So basically, we don't take them anywhere. We just send them back to where they originally came from. So it's basically case by case. And regarding the temperature limits question, so the temperature, basically, if I understand this correctly, you want to know what is the minimum and the maximum temperature that this membrane can take. So typically, anything between 5 and 35 degrees centigrade is ideal. You can go a little bit less than 5. You can still do 0 degrees C, provided that the water is, of course, not freezing. And you can do a little bit higher than the 35, up to 40 degrees C, but outside this 0 to 40 design envelope, we don't really recommend to operate the UF system.
Great, thank you. I think we've got time for a couple more questions here as well. Jamie, maybe you can take this one here. Talking about when a mobile asset is deployed over at a plant, who is the one that's operating that unit?
Well, typically we would provide, or at least propose to provide, a good amount of operational support training in the event that the facility has staff on site that can provide the daily checks that are required and report in any anomalies. And we also have our remote upgrade, remote monitoring program to allow us to watch the system. In the event that a plant does not have these operating capabilities, we can support the system further by providing more site support from Veolia.
Okay, looking through, apologize as I'm just scanning through the variety of different questions that we've got here again. Mo, maybe this one might be best for you as well here, but are there any applications that are not suitable for UF?
Okay, sure. So basically, not all the, UF is a filtration technology. So any application that is not suitable for a filter is not suitable for a UF. And in those cases, like for example, cases when you have spikes of turbidity of hundreds of MTUs, for example, this is not a suitable application for UF. For example, when you have wastewater that is loaded with heavy metals beyond the design envelope of the membrane system that requires some pre-treatment, this is not suitable to be fed as such to the UF system. So this is basically the cases where it's not suitable.
Okay, I think we've got time for just about one more question here. Again, Mo, I think probably again best for you, but can coagulants or flocculants be used ahead of the UF to improve performance, or will these harm the membranes?
Okay, so generally speaking, coagulants, yes, flocculants, no. The good thing about this asset that it does not really require coagulant to do the physical filtration. It is only required in cases where you want to target specific contaminants, for example, organics, for example, certain heavy metals in the water. And if you had to do that, and if you had to couple the UF with a chemistry piece up front to perform such a task, then our coagulant of choice would be alum-based coagulants. It is tested and they go very well with our membranes. Also, flocculants, I mean, generally speaking, no, especially cationic ones. They kind of irreversibly plug the membrane. And but smaller, very small dosages, in case tested and validated by the membrane supplier, we see that sometimes. But I mean, it's generally speaking, it's not recommended.
Great, thank you. I think that's all the time that we've got scheduled for today. Again, I do apologize if we did not get specifically to the question that you asked. However, we will follow up directly with you on that. And with that, I do thank you very much for your time today, spending it with us to learn a little bit more about ultrafiltration and mobile ultrafiltration. Just a reminder that at the end of the webinar today, you will receive a quick link or a brief link for a survey to fill that out. We do appreciate if you do take that time to fill that out for us. Again, should not take more than a minute or so. And then for those of you that do fill that out, you will be entered into a drawing for a chance to win a $25 Amazon gift card. And with that, that closes our webinar today. Again, we do appreciate that. And if you have any questions after this, feel free to follow up with us or ask those to us, and we will get back with you as well. So with that, that concludes our webinar today. Thank you, guys.